the two important terms of the control systems. First is controllability and second is observability. So let's start with our topic. In control systems, we deal with various types of systems. So a control engineer must have the ability to control and observe the systems. Control means that the engineer, it can have control over the states of the system. This controllability and observability, it is related to the state space analysis of a system. So if we say that the control engineer, it must be able to control any system. So for controlling the engineers, they have developed the controllers. And these controllers should have control over the system. It means that they can be able to control the states of the system. So controlling a system means that a engineer, it should be able to change the inputs to the system, and through the changes in the inputs, it is able to, or he or she will be able to control the states of the system. So that is related to the controllability. And observability means that the engineer can observe all the states of the system. So there was a scientist named as Kalman, and he defined the two terms controllability and observability with respect to the state space representation of the system. So let us see that what is the definition of the controllability and observability when a system can be said to be observable or controllable. Now, in state space representation, we define a system by its state space model. So here consider a state space model. So this is a state space model. Here this equation x dot is equals to ax plus bu. It is the state equation. Y is equals to cx plus du. It is the output equation. X dot is the state vector and u is the input vector. Y is the output vector. These are the three vectors. State vector is defining all the states of the system, and input vector is defining all the inputs of the vector. Output vector Y, it defines all the output variables of the system. A, B, C, D, they are the matrices. So this is a system which is defined in the state space form. It is the state space model of the system. Now, a system is said to be controllable. The definitions of the controllability and observability as defined by the scientist Kalman are: a system is said to be controllable if a control function ut at time at the initial state xt, this input ut is able to transform the state from the initial state to a final state. That is, whenever we apply an input, if we are applying an input to the system, that input is able to transform the state of the system. If it is possible, then that system is said to be controllable. It means that we as an engineer, we are able to convert the state of the system from one time to another time. Okay, like first the initial state is xt naught, and we are able to change it to certain different state like xt1 or xt2. So if we are applying an input and the state of the system is changing, it means that that system is controllable. So let us write the definition of controllability. So this is the technical definition of the controllable system, that a system is said to be controllable if a control function ut can transform the initial state xt naught of a system to some required final state xtf in a finite time interval tf minus t naught, where t should be greater than equals to 0. Now, what we are doing here, we are applying an input. This input is ut, and this input is changing the state from the initial state to the final state x t naught to x tf, and these changes are done by the control function ut. If it is possible in a system, then that system is said to be a controllable system. Now, observability means that the engineers or we are able to analyze or observe all the states of the system. We are an externally we can you analyze or we can observe all the states of the system. If all the states can be observed and measured, then that system is said to be observable. So a system is said to be observable if from measurements of the output carried over a finite interval of time, the state of a system can be determined. That is, externally we can observe all the states of the system. If externally we can observe and measure all the states, then that system is said to be observable. If some of the states cannot be measured and observed externally, then it shows that some of the states, they are shielded from the observation or they cannot be measured. Okay, so these were the definition of observable and a controllable system. Now Kalman, he defined that how we can measure the controllability and observability of a system. How, if the state model is given to us, then through the state model, how we can determine that this system is controllable and this is not, and either it is observable or it is not observable to us. So let's see that how we can determine it. So this is the controllability test defined by the scientist Kalman. So controllability test is defined as a system is said to be completely state controllable. The necessary and sufficient condition is that the following n cross nm matrix, it should have rank n. And this matrix QC is defined as B, AB, A square B till A n minus 1 B. N was our state variables. We were having n state variables. And A is our state vector, state matrix, and B is our input matrix. So through the state model is given to us x dot is equals to ax plus bu. So A and B are given to us. A was our state matrix, B was our input matrix. Then calculate this QC matrix. Put the first element will be the B matrix, second element will be the multiplication of A and B up till A n minus 1 B. So this matrix, if when you have completely formed this matrix, then calculate its rank. If its rank is equal to n, that is the n state variables, then this system is said to be completely state controllable. Okay, so this is how we can determine the controllability of a system. Now, if there is no connection between a certain state and input, because the definition of controllability says that we have an input and this input is able to change the state from the initial state to the final state, that is xt naught to xtf. So if any of the input is not connected to the state, then that system will have a rank less than n, and that system is said to be uncontrollable. Okay, so here we have if there is no connection between a certain state and an input, then that system is said to be uncontrollable. Now let's take an example that how we can calculate the controllability of a system whose state model is given to us. So let's take an example that how we can determine the stability of a system whose state space model is given to us. So we are given the state equation of the system and we have to find out that whether the system is controllable or not. So for controllability, we were having the matrix QC. We have to determine this matrix and it is given by B, A, B. Here we have n equals to 2 state variables. So we are going to, because the matrix it is up to A n minus 1 B. So here n equals to 2. So 2 minus 1, 1. So we are going to calculate up till B, A, B. Okay. Now state equation is given to us. So here it is the A matrix and it is the B matrix. So let's calculate AB. A is given to us as 5, 5, 0 and minus 5, and B is 5 and 0. So AB will be multiplication of these two. Five into 5, 25 plus 5 into 0, 0. So first element will be 25. Then 0 into 5, 0 plus minus 5 into 0, 0. So second element will be 0. So this is AB. Now our matrix QC will be B, that is 5 and 0, and AB, that is 25 and 0. So this is our controllability test matrix. 5 0 we have written our B matrix, and 25 0 we have written the AB matrix. Now we have to determine the determinant of this controllability matrix, because we want to check the rank of this matrix. So 5 into 0, it is 0, minus 25 into 0, it is 0. So our determinant will come out to be 0. So the rank is not equals to 2, because rank for a system to be controllable, the rank should be equals to n. N is here 2, but here the determinant is coming out to be 0. So its rank of this matrix is 1. It is not equals to 2. So this system, it is not controllable. Since the rank of QC matrix is not equals to 2, or we can say that it is a singular matrix. So this is a singular matrix. So the system is not controllable. For a system to be controllable, the matrix should be non-singular. So this is how we can determine the controllability of a system whose state model is given to us. Now comes observability. How we can check the observability of a system. Observability means that we can check, or we can measure, observe the state of the system externally. Okay. So for a system to be observable, so for a system to be observable, if the following n cross np matrix, because there are p outputs and n state variables, so n cross np matrix q naught, it is non-singular, then, or we can say that the rank of this q naught matrix is n, and this q naught matrix is defined by C transpose multiplication of A transpose C transpose, then A transpose square C transpose, till A transpose to the power n minus 1 and C transpose. Here n is the number of the state variables. So if this matrix Q naught matrix, it is a non-singular matrix, and the rank of this matrix is n, then that system is said to be an observable system. It means that all the states of the system, they can be observed and measured externally. Okay. Now if there is no connection between certain state and the output, then that system is said to be non-observable. System is said to be unobservable. Now, how we can determine the observability? Let's take an example so that you can easily understand that how this observability test is done. So we have to determine the observability of the system, and the equations of the system are given to us. Now the observability test matrix Q naught, it is given by C transpose A transpose C transpose A transpose square C transpose till A transpose n minus 1 C transpose. So here n is the number of state variables. Here we have two state variables, n equals to 2. So 2 minus 1, 1. That is, we are going to calculate this matrix up till C transpose and A transpose C transpose. So this we have to find out. Now C matrix is given to us in the question. So C matrix is 1 and 1. This is our C matrix. We have to find out the C transpose. Transpose of a matrix is the rows of this matrix will become the columns and columns will become the rows. So C transpose will be, here we have the row 1 1, so it will become the column 1 and 1. Now A transpose, it is, we have the first row as 0 1, so it will become the column, and second row as -2 -3, so it will become the second column. This is A transpose. Now we have to find out A transpose C transpose. Okay, so this will be, multiply these two matrices, 0 into 1 0 plus -2 into 1, so it is -2. Here 1 into 1 1 -3, so it will be 1 minus 3, so it will be -2 again. Okay, so here we will have Q naught equals to C transpose A transpose C transpose. Q naught is equals to, first column will be the C transpose matrix, that is 1 and 1, and second is A transpose C transpose, so it is -2 -2. Now we have to determine the determinant, because we want to check the rank of this matrix. So 1 into -2 -2 minus of -2, so it will be 0. Now determinant is coming out to be 0, so rank is not equals to 2. Because there are two rows, so rank is not equal to 2. One of the determinant is coming out to be 0. So this is a singular matrix and the system is unobservable. That is one of the state of the system. It is hidden. It is not, it cannot be measured or observed externally. It is not linked with the output. So this is how we can check the observability of a system. So we have checked all the systems. We have checked that how we can determine the observability and controllability of a system. Now, related to this controllability and observability, there is a duality property. This duality property says that if there is a system which is represented by this state model, by the state equations x dot equals to ax plus bu and y equals to cx plus du, then we have these matrices A, B, C. So if AB is controllable, then A transpose and B transpose will be observable. If AB is and second property is that if AB is observable, then A transpose B transpose will be controllable. That is reverse of it. If AB is controllable, A transpose B transpose will be observable. If AB is observable, then A transpose B transpose will be controllable. So in this video, we have studied about the two important terms, controllability and observability, related to the control systems, how we can determine that whether a system is controllable or not controllable, and the second test was about how we can determine that whether a system is observable or not observable. So I hope this topic is clear to you. Thank you.